Hello everyone, this is part 2 of the tracer series where I explain more about the traces table on EVM so that you'll be able to use the traces table easily. If you missed part 1, highly recommend you to check it out. In part 1 I talked about I gave an overview of what the traces table is, explained all the columns in the traces table, and we went through a quick guide on manually decoding the traces using simple examples like weth transfer, ETH transfer. So highly recommend you to check that out first before watching this video. In this video, I will be going into traces, decoding traces on a more in-depth level. We'll be looking at decoding call data where there are arrays involved, and slightly different rules apply. So I will also not be converting the relevant data into its appropriate data types, and what I mean by that is, so for example, let's say this first bit here is an address, and to convert this to an address, you just need to add you just need to subtract like the first 25 24 out, and then add OX in front. But all those I've covered in part 1, so again, if you missed part 1, do check that out. Okay, so let's get right into part 2. So part 2, what I want to look at is the Blur V2 marketplace. And if you don't know, Blur is an NFT marketplace, and they launched their second version of V2 sometime last year. Right, this is an example of a transaction where the NFT owner accepts offers on their NFT, right, and specifically accepts 4 offers, and so yeah, they get paid, and then he transfers out the NFT. So I'm using this explorer called Blocksec to analyze the trace table. So what I'm looking for is this delegate call, because like I mentioned in part 1, the contract here can make a delegate call, which means this function takeBit doesn't actually exist in this Blur IO marketplace 3 contract. Instead, it relies on an implementation contract, which is this Blur Exchange V2, that has this function in its contract. So it relies on this contract, hence it makes a delegate call. And so this specific call is what we wanna analyze. And hence, if you look at my query over here, I specifically spell it out like I want to address being this particular address, and the call being delegate call. Right, so this is just an example. Another thing I have to note here is that there is a easy decoded traces table for Ethereum, so you can use that. This guide is more for chains, so EVM chains where there is not yet a decoded traces table, and so you'll be able to decode it manually, right? Okay, so first thing I'm gonna do is I want to go to this contract and grab its API. So go to contract, scroll to API here, copy, and then this website for beautifying your JSON, which I love. It just makes it easier to view. And the reason why we want this API is because in this API there will be the function that we're looking for called takeBit, right over here, takeBit, and we're just looking for when here says takeBit. So there you go, this is the one that we're looking for, takeBit. You have to scroll a bit. Okay, so this is the one, right, number 60. And the reason why we need this is because this would tell us if there are if the type if there are types of if there are certain types of data that we need to apply certain rules. So for example, bytes is one type of data where we need to apply certain rules. The other type being arrays. So it's hard to explain, but it's somewhat like whenever there are whenever there are multiple arrays of whenever there are arrays of a tuple. So in this case, here it says there are arrays of tuple. So that means within this order, like order itself contains multiple variables, and there are multiple orders, and that's why it's an array. Okay, so we'll get into this, but first we want to know, we want to get the API, so that's done. The next thing we should do is to run this query. It's actually this handy query, if you remember from part 1, just segments the input column into lengths of 64 characters long, and so we get this column where yeah, it's all nicely in this column. So we just copy all this, paste into here, and we will get some organized array data that looks like this. I'm just gonna copy all of this and paste it in Studio like so, and then I am going to just work with the Studio data over here, right? So as I mentioned earlier, I will not be saying like something like let's say I know this is an address, element 4, so in the usual way of decoding, we need to say like segmented 4, which is this one over here, and then maybe something like substring 25, right? Take the whatever after the 25 onwards. I think this is like 40 characters, and then add a OX in front, something like this, right? As address, right? So I won't be doing this throughout this video. Instead, I'll just be telling you like what each of these lines mean, right? So what you're seeing here is a raw call data. If you look at blocksec and click on this call data, this will be exactly what you see as what I've pasted. So you see the first line here, bunch of zeros ends with 40 and then ends with 880. So it's the same right here, right? Ends with 40, then the second line ends with 880. So this is the call data here is exactly what you see here. And then where it is human readable form, blocksec already decodes it for you. And this is what you'll see in our decoded traces table as well. But for now, I'll show you how we can make sense of this call data in its rawest form. Okay, so there are a few rules. One rule is that there are things called offsets, and then another rule is that sometimes it tells you how many I guess elements are in the array, and then also offsets follow a hierarchy. And then last but not least, it's a bit of a guessing game when it comes to decoding traces manually. So I'll definitely cover all this as I go through this, right? So let's move to the first thing that we see, which is this 40-bit. Now what we have to do is we have to refer to the ABI, right? So this is our ABI, and you can see here it says 0 and 1, right? So there are two things in inputs, And how call data works is it follows a linear order, right, from top to bottom. It follows a linear order unless it unless there are certain unless it stumbles upon certain things. So for example, in this first input, instead of actually telling you the input, it is the offset. So offset means how many bytes are you have to disregard the byte, or like you have to skip the number of bytes before they reveal the actual information. So just some quick maths. 32 bytes. Um, 1 byte is 2 characters long, so 32 bytes is 64 characters long, which means 64 characters long, which means one line, right? This whole line here has 64 characters, and so 32 bytes means one line. Okay. And also all these are hex encoded, so you have to convert from hex to int, which is another website that I will open up. It's hex to decimal converter website. Okay, so let's convert this. This gives us 64. This is in bytes, and so 64 bytes means 64 divided by 32, which means it's 2 lines. So offset for input 0, which is the first input, 2, right? Essentially, there's 2 lines. The second one, 2688. 2688 divided by 32 is 84, and so offset for input 1 is 84. Okay, so we got first offsets, and let's look at what 0 and 1 is. So 0 is a struct, and yeah, it's called inputs. So it has a bunch of stuff, right? Like small stuff. Like the first stuff is called orders, and then he has this stuff called exchanges, and then taker fee, and then signatures. Yeah, so that's the first. That's the first input, which is called inputs. Not very helpful, but okay. The second input, or the second element in the array, is called oracle signature, and so this refers to oracle signature, or the offset for the oracle signature. Well, this is the offset for inputs. Okay. Okay. So one rule is called offsets follow a hierarchy. So notice how inputs and oracle signature belong in the same array, right? They belong within the same, I guess I call it hierarchy. And so because they belong in the same hierarchy, the offsets will start at the first line where the first hierarchy is. So let's say offset for this will start from here, and then offset for there will also start on here, because these two belong to the same hierarchy, and then the earliest line is this line. So when it says offset 2 lines, it really just means the first 2 lines starting from here is ignored. So 1, 2, ignore it, and the next line would be where we start input, right? Where we start inputs. Okay. You will notice that it is another hex, which means it is another array, and we'll get to that in a second, but we'll have to do, this is another offset again, right? Okay. But let's first do this, right? It says here 84 lines to skip, and that tells us the oracle signature. So let's skip 84 lines starting from the first line. So if I were to skip 2 lines, it ends up at 2, right? So if I were to skip 84 lines, our starting point is 0, so that means the 84th line will be the oracle signature. So let's go to 84. Yeah. Start of oracle signature. Right, so let's go back to our API. we see that Oracle signature is of type bytes, and because it is bytes, it follows another rule, which is this hex encoded number, string, is it represents the number of bytes. So again, convert this to bytes, right? 89. Length, I should say here, length of Oracle signature. So 89, because one byte has 2 characters, so this would be 89 times 2, 178. Okay, 178 characters long. Okay, and the next 178 characters would be the Oracle signature. So whatever this is, this last 3, I'm assuming, is the Oracle signature. You can verify this by just adding up, right? So the first line is 64, second line is 64, and the last line, if you were to count, right? So 2, 4, 6, 8, 10, 12, 14, plus 64 minus 14, 178. There you go. So that means all of this from 9B all the way to 6E, 6CE, that is the Oracle signature. So we've already decoded the one of the things. Okay. All right. So this is done, right? Let's go back to our inputs. It's called inputs. Okay. So inputs have 4 components, right? 0, 1, 2, 3. So there are 4 here. And the first component is an array of tuple, and then this bracket means array, right? Which means, and then if we open this up, there are a bunch of components, right? Which means there are multiple orders, and each order would consist of all these 8 components, which is trader, collection, listings, root, number of listings, etc. So there are multiple orders, and so because there are multiple orders, it first has to tell you what is the offset needed for the order. So let's see. Okay, right. So offset for order, and then the next in line would be exchanges. Again, it is an array, so there are multiple exchanges, which means the next line is offset for exchanges. Okay, and moving on, take a fee. It is not an array. It is not an array, so it's just recipient and rate, which means we can just use the data as is. So this will be recipient, and then this will be rate. So this is as an address type, and then rate is a integer type. So convert this to hex to int. Your rate is 50, right? And that might be 50 pips. Okay, next. We've done take a fee. So next is signatures. Another signature. This time it is just called signature, not Oracle signature. And so this one, because it is bytes, we have to, there is an offset for bytes. So offset for signature. Okay. Right. So we're done with the first input, right? Sorry, we're done with inputs, and so now since there's nothing left, we have to go back to the offset for order, and then try to move on from there. So we know that this is the offset for order, so again convert this from hex to int. 160 divided by 32, I think that's 5. Okay, it's 5. 5 lines to skip, and then 420 1056, 33 lines to skip, and then 940 is 2368 74. 74 lines. Okay. Now, because order exchanges, recipient rate and this signature all belong to the same hierarchy, which is the hierarchy of inputs, right? All these four belongs under inputs. They all start the offset from this line, which is the earliest line for within this hierarchy, right? So here it says order starts after skipping 5 lines. So the first line being this, so 1, 2, 3, 4, 5. And the next line would be the start of order. But we see that there is a number 3 here. And this goes back to this rule where it says it tells you how many elements are there in the array. Or in this case, it tells you how many orders are there. So it tells us how many orders are there. So in this case it's 3, right? We do have to convert this from hex to int. I think, if I'm not mistaken, but it is 3 in this case. And so now we have to go back to orders, which is here, and then look through the components. I don't see any arrays, but there is a byte, so there will be an offset after this. But besides that, it's just a straightforward component. So we will just copy paste all of this. So for example, the first one here being trader, and then here being the collection or the NFT address. And if we're on this at this point, we can also verify with the block explorer to see if what we're doing is correct so far. So let's say trader is 0x77e. Trader is 0x77e, right? This is the one over here. And then collection is 5AF. Collection Milady token is indeed 5AF. So this is correct so far. So let's keep going down the line in this API. So we have trader, collection, listings root is bytes, but looks like we don't have to offset here because this seems like the listing root. So I'm just gonna confirm that AE4, yeah, it is the listings root, so I don't have to have an offset for that. Offset, sorry. I don't know why. Maybe because it already specifies bytes 32. Okay, number of listings, and then expiration time, asset type, and then you have two components, recipient and rate. So recipient, and this is rate, and then number 7 is salt. Alright, cool. Yeah, so this is order 1. So maybe let's label this order 1. Order 1, right? And because there are 3 orders, order 2 will immediately follow at the end of order 1. So order 1 starts here and ends here, right? The next line will immediately be order 2, and the sequence of the components is the same. So this would be trader, because order 1 starts with trader, order 2 will also start with trader. Alright, so everything's same, so that I'm just going to count how many components are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be the same for order 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. End of order 2. And this will be trader, or the start of order 3. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So end of order 3. I think that looks good. So the end of order tree is a salt that starts with 0901. So let's try to find salt 0901. Oh wait, this is this needs to be converted from hex to int. Okay, so it's 191519, which is this, right? So this would be the end of order tree before we move on to exchanges. So this is correct. Yeah, so we've successfully decoded all the orders, all the three orders, and like I mentioned, to get the actual things, you do need to convert this from all these hex to either an address or an integer appropriately, right? Okay, so after order, what is next? Next is of course exchanges. So exchanges would be skip 33 lines from this line over here, because this line is the earliest line within the same hierarchy. Okay, so if it's line number 2 and I skip 2 lines, it'll be line number 4, right? So that means whatever number I add to 2, that number would be where I start exchanges. So 2 plus 33 is 35. So that means the 35th line is where I will start exchanges. And this and indeed, the 35th line is where exchanges start, since it's the end of order. So start of exchanges. And I wrote 4 here because here states 4, and so there are 4 exchanges. Again, hex to int of this would be 4, just to show you 4, right? So that tells me there are 4 exchanges. So there are 4 exchanges, and notice how the following line is it looks like offset as well, right? And that is because, and this is where a bit of a guessing game comes into play. That is because instead of telling you all the 4 exchanges, it tells you the number of offsets you have to do again, right, for these exchanges. So yeah, offset for exchange 1, right, and then offset for exchange 2, etc. Maybe I'll just copy this. 3, 4. Okay, so again, convert this from hex to int. 1 to 8. 1 to 8 divided by 32, it's 4. 4 lines, right, to skip. 4 lines to skip. And then 416 is 13. This is 704. 2, 992, 31. Alright. Another thing I'm noticing here is that the difference between the offsets are 9, so 4 plus 9, right? That tells me the number of components for each exchange is 9. So there are 9 components for each exchange, and there are 4 exchanges. Okay, so offset, again, these 4 belong to the same hierarchy, so offset would start here. So 1, 2, 3, 4, and then the first line of this would be start of exchange 1. And exchange 1, let's go back to the ABI. Exchange 1 is index, so it's index. Let's just call it like this, right? Index exchange 1, and then this is proof. Oh, so notice how it says bytes into array, right? Which means this is the offset for proof. Also because this doesn't look like a proof, right? It looks like an offset, so that's how I know. let's try to find out what this number is. 2568. So it's okay, what's next? After proof we have another index, but this index is called listing. So listing index. Listing index. Listing token ID, right? Listing amount. Listing price. And then we have taker. So taker token ID. Taker amount. Token ID amount. I think that's it. Yeah, that's it for exchanges. So let's verify. So we know this is the token ID, so let's convert this 9531. So let's find the first exchange. The token ID should be 9531. There you go. So 9531 is indeed token ID. So this is right. There is an offset here, which is 8 lines, and the hierarchy for this would start from here because this is the start of index 1. So 1, 2, 3, 4, 5, 6, 7, 8 lines to skip. So this would be proof, and the proof is just a bunch of zeros. That means there's no proof. Yeah, there's no proof, which is evident here. Actually, it should be somewhere in front. Yeah, there you go. This is the first exchange, and then there's no proof. And I think since that is it, the next would be the index. The next would be the index or the start of exchange 2. Now let's verify this by looking at the offset for exchange 2. It says 13. 13 lines to skip. So exchange 2 belongs in this same hierarchy as exchange 1. So which means we're starting from the line 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Oh, looks like there's something wrong. 13 lines to skip. Line should be. It should be here. 13 lines, which means 14. Wait, how am I counting this? Yeah, it should be. Right, so this is the first line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Oh, it is correct. Okay, so 13 lines to skip, and then the next line is the start of index 2. Okay, awesome. So it lines up. So index, the start of exchange 2 is indeed here, and again the rest of the things will be the same. So I'm just gonna count how many stuff are in index. In exchange 1. It should be 9 because there is a difference of 9 between all the offsets. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So indeed it's 9. So again, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So end of exchange 2. And then the start of exchange 3. Again 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Exchange 3. And then this would be exchange 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So end of exchange 4. Alright, so yeah, we finished exchange. What's next is let's look at the API. So there are 4 components in inputs, right? The first component is called order. There were 3 orders. We've done all 3. The next is exchanges. There were 4 exchanges. We've done all 4 exchanges. Next is the taker fee, recipient and rate. We've already done this here, right? Recipient and rate, right? Order, exchanges, recipient, rate. And then the last but not least is signatures. And here we have offset for signatures, 74 lines. So Offset for this group starts off here, which is the second line, and so 2 plus 74, the 76 line, the line number 76 will be the start of signature. So line number 76, there you go, see it all lines up perfectly, so satisfying, right? So start of signature, or because it's bytes, the length of signature. Convert this from hex to int, 195. 195 bytes times 2 is 390. 390 characters long. So let's try to count this. There are 1, 2, 3, 4, 5, 6. 6 times 64, right? So all these 6 lines are 384 characters long, and then the last line is 1, 2, 3, 4, 5, 6. Plus 6 gives us 390, which is exactly the length of the signature, right? And that's it, right? Also for bytes, they write pad 0 all the way to 64 characters, so that's why there's a bunch of zeros here. But that's it. We basically decoded the whole call data for Blur v2, right? All 87 lines. 87 lines, how many characters? 5,568 characters. Damn, it's pretty cool. Yeah, I think that's it for this video. And basically that's how you would manually decode I guess more complicated structures, right, with the arrays and bytes involved. Yeah, I hope that was helpful, and leave a comment if you made it all the way here. And that's it. Thanks for watching. See you in the next one. Bye.